Assalamualaikum and a very good morning. My name is Intan Nur Haslinda binti Roslan and I would like to present my individual lab report on hydrostatic pressure. Let's start with the introduction of this experiment. When an object is submerged in a fluid, force is exerted on the surface of the object due to the weight of the fluid. The force is called hydrostatic force. Meanwhile, the center of pressure is a point on the immersed surface at which the resultant hydrostatic force acts. In this experiment, there are two objectives to be achieved, which are first, to determine the hydrostatic force acting on a plane surface immersed in water when the surface is partially submerged or fully submerged. Next, we need to determine the experimental and theoretical center of pressure for each trials performed. The idea of this experiment is that the hydrostatic force and center of pressure acting on the vertical surfaces will be determined by increasing the water depth in the apparatus water tank and by reaching an equilibrium condition between the moments acting on the balance arm of the test apparatus. The forces which create these moments are the weight applied to the balance arm and the hydrostatic force on the vertical surface. The following shows the setup of the experiment, which mainly consists of weight hanger, quadrant, counterbalance, and balancing arm. The experiment can be conducted using the following procedures. First, measure the dimensions of the quadrant, vertical end face, and the distances. Second, wipe the quadrant with a wet rag to remove surface tension and prevent air bubbles from forming. Third, place the apparatus on a level surface and adjust the screwed-in feet until the built-in circular spiral level indicates that the base is horizontal. Fourth, place the weight hanger on the end of the balance arm and level the arm using the counterweight so that the balance arm is horizontal. Fifth, add 50 grams to the weight hanger. Sixth, add water to the tank until the water overtops the horizontal plane of the quadrant. 7. Record the water height. If the quadrant is partially submerged, record the reading in the partially submerged portion of the raw data table. And lastly, repeat the steps, adding 50 gram weight each time until the final weight of 500 gram is reached. When the quadrant is fully submerged, record the readings in the fully submerged part of the raw data table. We will discuss the formulas to be used in this experiment. To determine the hydrostatic force, the equation F equals to rho GYCA, where YC stands for the centroid of the immersed surface. YC can be obtained from the measurement of B, D, and small letter d in order to further derive the equation to find hydrostatic force for partially immersed or fully immersed vertical plane. To determine the theoretical center of pressure, the equation Yp equals to Ix over Ayc can be used. Ix stands for the moment of inertia of the plane and can be determined by equation of 6a and 6b for each partially submerged or fully submerged plane surface. Then the equation can be fully derived to equation 8a and 8b. Meanwhile, to determine the experimental center of pressure, the equation mg times L equals to F times Y can be used. Since mg, L, and F is known, we can determine Y by deriving the equation into equation 9a and 9b to get the center of pressure for partially submerged and fully submerged plane surface. This is the results of the experiment. As we observe, when the mass increases, the depth of immersion will also increase. Besides, when the depth of immersion increases, the hydrostatic force exerted on the plane will also increase. Therefore, the more you submerge the plane, the more hydrostatic force will be exerted on the plane. However, for the center of pressure, there is a significant difference between the theoretical and experimental value, which is shown by their large percentage error, ranging from 8.76% to 44.3%. The following discussion can be obtained in this experiment. First, the hydrostatic force act on any point on the quadrant surfaces is normal to the surfaces. Second, the hydrostatic forces act on the sides of the plane cancel out each other since they are in opposite direction. Third, the force act on the curved surface is resolved by the pivot point as it is the center of the radii. And fourth, the hydrostatic forces exerted on the plane is balanced by the weight on the left side. In conclusion, the objectives of this experiment is achieved, which is to determine the hydrostatic force and center of pressure in the plane surface. Next, hydrostatic force was determined experimentally. Third, center of pressure was determined theoretically and experimentally. And lastly, the error for center of pressure was extremely high, which is 44.3%, which may caused by several errors during the experiment.